the idea of cloud computing is that there's all this, today, you have to think about infrastructure in discrete units. You have to buy racks, provision bandwidth, rent data center space, hire people to write code, all sorts of different things. But you don't do that for electricity, right? Electricity, you plug your toaster in the wall, and the vast majority of the time, the toaster just works. And so what if you can turn computing at all levels of the stack into a utility where people no longer have to go out and build their own power plant, but rather can plug into a grid, if you will, and consume what they need on a metered basis. And so there's a pretty slide that I stole from someone. I wouldn't have done that much work. So what does that mean for, what is cloud computing? So the point of this is, really the internet, this idea that everything is network connected, makes it possible to turn these computing resources into a utility the same way we have a power grid that delivers power to your outlet. And so, at the simplest idea, what EC2 allows you to do is call an API that says, here's an image of a machine. This is what I want a machine to look like. And by the way, I want 3 of those. I don't need 3, I need 300. And through a simple request, which is synonymous with what happens when you request a web page, you're able to, obviously there's some authentication and some account stuff going on in the background, but you're able to actually launch as many or as few of those as you want. And so this very basic primitive, this ability to say, clone this machine, create 300, run them for 24 hours, and then shut down the 50 and run it for as long as you need it, is kind of a very basic cloud computing primitive, but it enables so much. Instead of calling your IT guy and telling him you need 6 servers and you're going to need possibly 12 more 3 months after that, and then if things really take off, you're going to need 100 set aside because you might get slashdotted or Facebooked or whatever the latest and greatest way to get viral adoption is. It simplifies. Likewise, storage, rather than going out and provisioning a bunch of servers and figuring out how to install software that replicates the data back and forth, you call an API that says, I want to store this object with this name. And then when you retrieve it, you use the name. And so these are just 2 very basic cloud computing primitives, but you can imagine that over time, you can compose a whole suite of interesting compute, storage, database primitives that allow people to build systems in a way that they have to know very little about what's going on with the infrastructure. And so that's, in my mind, the most basic view of what cloud computing is. And now you'll hear a lot of people talk about infrastructure as a service and platform as a service. And these distinctions are not terribly meaningful to me. To me, there's a spectrum of things that people want to do. In the computing industry, it turns out that engineers often need to have complete control, but lots of times they're happy to do things way up the stack in a very abstract way because it's easier and it gets them to market. But really what they want is a view of their resources at every different level. And so, you start debating with people about, S3 is the storage service we have, and it has this API that says, store this object with this name. Is that infrastructure, it's storage, or is it a platform? It's actually doing quite a bit behind the scenes. It's creating an index and storing the object. And so to me, these variations are interesting to people that have a lot of time to spend thinking about these things. But essentially, all of these services boil down to taking what used to require installing a bunch of libraries and configuring a bunch of machines and turning it into an API that people can call over the web. Again, these are not my slides. So this is the idea of, this is what Amazon, this is what we would show a customer if we were describing what Amazon Web Services is. I stole this from a customer deck. It's a cloud computing platform that provides flexible, scalable, and cost-effective technology infrastructure for businesses of all sizes around the world. And the idea being that we've utilized all this experience that we've built up over time. So the idea here is we're taking what we've built internally and making it readily available to customers via these web service APIs. So this is the key value proposition that resonates with customers. We call it muck. I think we've called it muck. I think Jeff's called it undifferentiated heavy lifting. But the idea is that if you kind of took a snapshot of one of these teams in Amazon or a startup 5 or 10 years ago, and you looked at where they were spending all their time, right? They were spending, unfortunately, they were spending the majority of their time doing things that really had no tangible benefit to differentiating them from their competitors, or no tangible benefit to improving the customer experience of the service they were providing. And so this is what we loosely call the undifferentiated heavy lifting. This is the guy on your team that has to call the guy at the colo provider to reserve a rack space, and then find the website that has the best deal on memory to plug into the server. Or so all of this time and energy, and then worse yet, once you have it running, keep it running. So the guy who's got to make sure that the power stays on and the network stays on and that the building stays cold enough and that the software that's storing your data doesn't have any bugs that catastrophically loses your customer data. And so it turns out that if you looked at the profile of the average team at Amazon, or even the average startup, the vast majority of their time is spent on this undifferentiated heavy lifting, and some amount, the 70-30 is obviously just a swag, working on things that really matter to customers. The idea of cloud computing, the idea that we had with AWS, is to flip that equation around so that most of the time is spent working on things that are important to your customers, that are important to your business, and less of your time is spent on the undifferentiated stuff that is really just the cost of doing business. And so obviously over time, you would imagine that this amount of time should shrink more and more as cloud computing and cloud services become more and more robust and more functional. And in fact, I'll talk about that a little later. But this goal is to flip this equation and to get this sort of really disruptive change. And so hopefully what you'll see when you have these conversations down the road is you'll see when you look at startups that a lot of what's exciting about the startup community today is if you look at what they can do with $100,000 and 3 people, it is not even comparable to what they could have done with $100,000 and 3 people, which might have allowed them to purchase 10 computers and run for 1 year, whereas now they really can spend most of that money on the people writing the software and only pay for the computing resources if their business idea actually finds success. So when we highlight the attributes of cloud computing, we talk about a few value propositions. I want to leave lots of time for questions and stop using slides. So we talk about no capital expenditures. We talk about this utility pay-as-you-go, pay for what you use model. We talk about elasticity. So we actually thought this proposition was so important that we put it in the name of the compute service, but this idea that you can scale up and scale down based on your customer demands. And then the last two kind of go to that removing the heavy lifting, removing the muck, but this idea that we're actually innovating to get rid of the undifferentiated heavy lifting. This is another sales and marketing slide that I stole, but it gives you a sense of the sort of things that we consider when we talk about Amazon Web Services. EC2 and the sort of compute-related services are obviously there in the middle because they're so important, but there's lots of other things, storage and database services, messaging, tools for managing your network, developer tools, so there's a whole bunch of stuff. But the primary idea is take what was once delivered as physical goods, hardware, and bits that people had to install and figure out how to run for themselves, and find a way to run it as a service for them. So you can give them SLAs and you can give them the ability to consume it without reading the 600-page user guide and spending all that time on infrastructure provisioning that we just talked about. This is a random list of common use cases, but the reality is that cloud computing can be used for anything that computers can be used for. And in fact, I can probably, if you name a problem space, I can probably talk to you about a customer who's using EC2 in some unique way. Hedge funds are using it because they can spin up large amounts of compute before the market opens and during the course of the day, and then shut them off when they're not using them at night. Social gaming and social media companies are using it because they can scale up and scale down to meet the viral traffic that's generated for their app. High performance computing, business process data, scientific computing, all these folks are finding value in getting away from the muck of managing their own hardware and harnessing the elasticity that's provided by cloud computing. There's a bunch of customers that are using it. Yeah, great. A lot of partners are providing. And you may be talking to a bunch of these people. I hope you'll hear from. But a lot of people are building on top of. And again, I talked to you about those layers of functionality. There's no reason why everything that people do with a computer can't ultimately be delivered as a service. And you're seeing this trend in other areas if you think about it, right? Your a cell phone is harnessing a bunch of data, and everything's moving to this model where it can be provided as a service rather than it has to run on your laptop or your computer or your PC sitting in your house. So now we're back here. So I think the question that people asked me to talk about was kind of, what's so interesting about this? Why is it hard? And so I could probably talk about that for hours, but I figured if I went back to these value propositions that I talked about earlier, it might be an interesting way to present some of the problems that we tackle, and that specifically that folks like you guys are helping us tackle. So if you kind of look at the first one, the no capital expenditure, that's the benefit to the customer, right? And so, well, great, that's awesome, but it turns out that behind the scenes we are building a rather capital-intensive business, and so I'm assuming you guys have done a little learning on the nuances of capital-intensive businesses, but they've got a bunch of problems. So for us to, there's lots of realities behind the scenes with our capital-intensive business. For example, you don't buy a rack at a time. Rather, you buy big data centers. And those big data centers are on land that often needs permits to be built, and then a bunch of heavy-duty electrical gear like massive generators and fans and security systems and all sorts of stuff that likely has to be provisioned in advance. And so it can take you, conservatively, weeks or months to build one of these buildings, and depending on the geography in the world, it could take you much longer if the permitting process is such. You have to then, of course, get the servers in, which has got all sorts of supply chain issues because there's literally hundreds of parts that make that server up. And so if at any time there's a flood in, pick your favorite Far East or North American region, you could face a shortage on any number of critical parts. You could, of course, stockpile all that stuff, but then, of course, there's capital implications to that as well. You're increasing the amount of capital you're taking on. So there's a whole bunch of scale benefits, but for us to take advantage of those scale benefits, we're going to have to do a whole bunch of interesting work behind the scenes. To kind of put that in perspective, our services today run in multiple locations. This is a slide that I stole that's out of date, so this is kind of fun. The little boxes are meant to represent where we have large regions. Regions are essentially geographically distinct areas where customers can sort of place their computing resources. And so people want to place things in different places for lots of reasons. The primary one is latency. You actually want your computers to be close to your customer, but there's lots of other reasons. Legal constraints might require you to keep data in a particular place. So customers ask for more than one of these. From our perspective, of course, if we were merely thinking about the capital equation, having one big region would be awesome because all of the sort of activity is in one place, and we have a bigger pool. The bigger the pool is, the easier the capacity management problem is that I'll talk about in a minute. But the reality of life is customers want these things all over the place. So today we have, it's a really dated slide. We've got one on the east coast of the US, we've got one on the west coast of the US, we've got one in Europe, and we've got two in Asia, one in Singapore and one in Japan. All the little stars are smaller computing centers that we use primarily for CDN, which is a service we provide as well as a cloud service to help people distribute their content and really drive down the last mile latency for customers. But you can imagine that as this is probably not, we're probably not done here. Like, as I said, there's reasons why we have to be in other locations, and every one of those locations brings about its own logistical challenges, as well as making our pools smaller. It'd be much nicer, and you can figure out why if everything was in one place that we could deal with one pool. Now, each of these little boxes actually is multiple locations of itself because for fault tolerance reasons, so people can write reliable apps, even within one location, they don't want all of their stuff in one building because that building could be hit by a meteor. If the building's hit by a meteor, the first thing people worry about is whether or not the Facebook's up or whether or not their favorite social game is up. And so companies, I'm kind of joking, but there's other things that can take out a building besides a meteor, and people don't want their websites down. So within the region, we have what are called multiple availability zones, which give people the ability to run across physically distinct infrastructure that's separated by large numbers of feet, miles, depending on what the math, the actuarial data would tell you need to do in order to provide high availability. So so that further complicates the capital equation. Oh, there we go. Oh, moving right along. So if we take the second two value propositions, these are essentially elasticity and this ability to pay as you go. I kind of artificially separated from the first one, but this basically makes the first problem even harder, right? So we've got this big capital-intensive business that we're essentially selling to customers as a pay-as-you-drink model. Meanwhile, we're telling them, hey, look at us, we have infinite capacity. You can use as much as you want or not. And so we've got to, first of all, we've got to build all of our services to scale, which means, of course, the engineers have to do a good job of building things right, but it means that the product managers and the general managers need to define the services in ways that are useful to the customer, but can be built reliably. And while that problem may seem easy, it is not. You can build all sorts of things. There are all sorts of things being used today to provide computer systems that cannot be scaled reliably indefinitely. And so in computer science, we often talk about things that scale up versus things that scale out. And the concept of something that scales up is as you put more demand on the system, you need to buy a larger and larger system. And this kind of goes back to the days of mainframes. Well, the problem with the larger and larger system is the costs don't scale linearly, they scale exponentially. There's also a whole bunch of stuff in the real world that is not possible to replicate across multiple geographies. So while you can get a degree of high availability within a single location, you cannot protect yourself from that meteor or similar calamities. So these kind of compound the problem. To give you guys some sense of scale here, this is, we don't talk about too much in terms of actual scale, but this is the number we use to help people calibrate sort of the rate that these things are growing. This is a by-year look at the number of objects that are stored in S3. S3 is our storage service that I kind of alluded to earlier, the one that says basically put get. And so you can see that back in 2006, which was the year that we launched, is that true? It is. That is the year we launched EC2, and it is the year we launched S3. We had about 2.9 billion by the end of the year. At the end of last year, we had 262 billion objects, and that number, I think we've even updated that number, but it's still growing with the similar curve you see there, which is not linear. Okay, so here's the EC2 problem. This is a problem actually across the board. This is labeled compute power and time, but you can label this network capacity. You could label this storage. You could label this anything. This is ultimately kind of an illustration of the problem with over and under provisioning. But the idea is that you really don't know where your business is going to go, so you have to predict that usage. And so typically smart folks like you meet with a whole bunch of people in engineering and say, hey, let's try to figure out how well this service I just built is going to be adopted, and you make some projections, and you try to correlate it to something interesting, and at the end of the day, you're just taking a guess. And so you get a guess, and you end up with one of two things, unless you're really lucky. One is that you end up with a whole bunch of waste because you provisioned a bunch of resource that you don't need, or you end up with an outage. Most of the time, larger companies will prefer the former to the latter, and smaller companies are usually forced to prefer the latter to the former, but either way, things are not happy. So what does EC2 allow customers to do? So this is a graph that shows the actual number of instances being run, I think on an hourly basis by a customer of EC2, an unnamed customer of EC2, who's apparently running a quote-unquote Wall Street app. But you can see that this customer tends to run some sort of process every day, presumably doing something, analyzing some data related to the market, and shuts it down when they no longer need it, and goes away over the course of the weekend. And so you can imagine if you've taken calculus, or even geometry in this case, if you integrate the area under that line, it's going to be much better than if you put a straight line across. In fact, in this case, I think that you're probably utilizing those resources roughly 50% of the time, and so you're probably buying twice as much computing power as you need if you have to pre-allocate to your peak rather than buy by the SIP. Whoa, look at that animation. This is a graph we like to use, which illustrates the sort of viral // Twitter effect, which is, this is a video app, which we've actually talked about as Animoto. Animoto actually is one of the founders of Animoto is a Dartmouth alum as well, who I know quite well. I think he's a 2000, and it has taken off quite well. This was a graph from 2008 when they were first starting out. I think they've been running for a couple of years, and their app, has anybody used Animoto? Yeah, so it allows you to upload photos and I think choose some music, and then it does some pretty cool stuff with animations in terms of helping you create basically a video. But there's a lot of compute power necessary behind the scenes. Right around this time period, early summer, late spring, depending on where you're living, the Animoto guys got posted on Facebook and took off rather aggressively, and so you can see this is the compute demand. There is no chance that they would have been able to provision for that peak or even known that peak was coming, but rather their ability to scale up allowed them to get to basically do a whole bunch of creative stuff on the marketing side, and when they finally struck on something that worked, they got a ton of traction, and these guys are still going strong today and doing some interesting stuff. There, and in fact it wasn't launch of the Facebook, but rather they modified something so that it popped up at different contexts, and for whatever reason, popping up in that context led people to use it more, which is, there we go. So, what do we do about these problems? These being the first three problems, really it's two things we have to do. We have to innovate and we have to operate. There's other details as well, but really those two things are driven by our product managers, and so that's why I bring this up. On the operate side, we have to do things like capacity planning. So we have to build systems and business logic that reasonably predicts the amount of usage that's going to happen a week from now, an hour from now, 6 weeks from now, 12 weeks from now, a year from now, since some locations we have to think about, like Asia, Japan is not an easy place to go find a building if you have to do it on short notice. And so capacity planning is a big problem. And obviously requires a pretty specialized skill set. Supply chain management is, there's the obvious parts of supply chain management, which is to do it by hand, but then there's what we need to do, which is to innovate in our supply chain and really think about how do all these pieces come together in the data center, and what can we do from a business perspective with the vendors and the various component providers and the various ways that we deliver this capacity to actually reduce our cost structure. But also, very important for our business is to increase the flexibility to allow ourselves to react more quickly. If we can shave a day or a week off of our ability to provision new capacity, we can run the service hotter while delivering the same customer experience. And so that's a big lever for our business. And as the business gets bigger and bigger and bigger, and this is true of any cloud service, our ability to innovate there increases. And then another great example is actually the product definition itself. And so EC2 originally launched with a single pricing model. It was, I like to call it the Henry Ford model. You could have a single instance type for 10 cents an hour, as long as that one size fit you, kind of like Henry Ford and his black Model T Ford. But it turns out that people want compute in all different kinds of sizes and shapes, and not everybody wants this one pricing model. So everybody loved the pricing model, actually, because what they loved about it was the fact that they didn't have to tell us, and they could come and they can launch as many instances as they want. The problem with that is there's always a number X, which is bigger than the amount of capacity that we have. Doesn't matter how much capacity we have, somebody can come and say, I want, if we have 1 million computers available, they could ask for 1,000,001. And so there's always a possibility that we're going to tell a customer no. And so we have to do lots of work behind the scenes, back to the first 2 points on capacity management, supply chain, capacity planning, to try to never say no, because if we say no, it breaks the whole illusion of cloud computing. However, we also need to find clever ways to price our service. So one interesting tension of this is for on-demand, in order to never say no, we have to carry a bunch of excess capacity. Well, now we're sitting on a bunch of capacity that we're not using. It's literally sitting there in the data center empty. And so this is waste. And where there's waste, there's probably opportunity. So we can't actually allocate that resource to a customer, or else it does us no good because we can't evict them when we need it. So we started innovating on different pricing models. The pricing model we came up with is actually Spot. And so there's Spot instances, you can go look at our detail page, is actually an auction model around excess capacity, around instances. And so rather than say, I would like 50 instances right now, you say, I would like 50 instances and I would like to pay no more than 3 cents per hour. And there's a spot price, which is based on the supply of capacity and the demand of customers that are willing to tolerate this sort of capacity. And if the price fluctuates, we launch and terminate instances to make that nice little clearing price work. The downside of that for the customer, the upside is they get cheap compute, which actually enables a whole bunch of things to be computed on that were probably uneconomical previously. The complexity for the customer is that we could come along at any time and evict them because we need that capacity to service other customer demand. So this allows us to monetize to some extent our excess capacity, while at the same time providing value for customers that never existed in the real world before. The challenge, of course, is to get folks to rewrite their applications in creative ways to take advantage of spot instances. Most applications, most software in the real world is not written in a way that it can take advantage of hardware that sometimes disappears. But it turns out that logically you can think of a ton of different problems that could take advantage of it. Take any of the research departments at universities where they want to do, there's always more permutations of a particular scientific algorithm or analysis that they want to do than there is available computing horsepower on whatever compute structure they have. And so if they have a budget in a long enough period of time, they can set their bid price to allow them to run a whole bunch of different simulations than they would have been able to do on their sort of dedicated hardware cluster. And so we're seeing great adoption of Spot, but there's a whole bunch of stuff we need to do from a product perspective to make that easier and easier to use. And so, ultimately, that I believe is a great example of innovation. I won't talk about reserved instances because we don't have that much time, and they're not as interesting. We're almost done here. So the other two challenging things is all about this removing of the muck. Well, so this is all about innovation, right? How do we actually do this? Well, we have to go out and we have to understand what customers are doing today, and we have to understand how we can change our services to remove more muck. And so as much as I'm happy with what we've built so far with AWS and EC2, customers are still doing way too much work for themselves. And we need to continue to find ways to innovate on behalf of the customer to make it easier and easier to do all the things that people are doing with these services, and ultimately expand the addressable market of things they can do with these services. And so to give you a visual representation of this, we launched EC2 back in 2006, August 25th. It just hit its 5th anniversary, I think. And this gives you a good sense of the rate of change that we are producing. Our desire here is not to have this tail off, but rather to expand that rate of change. And I can tell you that every one of these product changes requires a significant amount of thought to do right. You can do a lot with sort of innovation, but you have to be careful to make changes that are digestible to your customer, but also make sure that you're not, you want to be bold and do interesting things, but you want to do them in ways that you can learn before you have to commit to a certain way, because we really are creating a new model here, and if we get it wrong, we can lose a lot of the potential, right? And so none of these things are easy. That's the end of the slideshow. So there you go. We have 10 minutes left, and I'm happy to take questions. I'll start in the middle. Yes?
How do you think about security?
So one of the things I would have said if you were asking me to just generally present, kind of when I think of security, we like to think of things in terms of tenets internally, and there's no doubt in my mind that security and operational performance are sort of our top job. And so as great as all this innovation is, the business doesn't work if we don't focus on security. Now, fundamentally, I believe that there is nothing that we can be more secure in a cloud than you can in your own data center. There's more smart people looking for threat vectors. There's more that you can do with sort of data in terms of things that are happening. There's more tools that you can make easy for customers to adopt. So, the great thing about the real world is there's a bunch of stuff you can do to lock down your data center. But lots of people have to go out and read the manual and figure out what makes sense. And whereas in a cloud environment, we can start to steer people towards secure in easier and easier ways. And so I firmly believe that cloud computing will be more secure than traditional on-premise computing. I also firmly believe that from our perspective, this has got to be our top priority. So if we believe there's a security problem or an operational risk, those things take priority over any of those stuff I talked about. Yeah.
Are there any sort of major business changes you've made since the April EC2 outage? I'm sure there's been a lot that you've done to your wellness like
Business
this.
changes. No, I don't think there's. So, we've always had the statement I just made has always been. You can look back at our internal planning docs for the last 6 years, and you'll see, operational performance and security are job one, and we've never shipped anything that we believed had operational exposure. We've had a really good track record in terms of operational performance, which has a lot to do with how quickly the space has grown. April was obviously a very significant issue for us in a number of different ways. Obviously, internally, we made some adjustments in terms of our resourcing to make sure that we doubled down and fix those. It also, as we you see a postmortem that we posted after that. We also use that learning as we do every issue that we have to help us think through other exposures that we have that might not be blatantly obvious. It's not like, oh, I stubbed my toe on the bed, but rather, where else in my house might I stub my toe? And that exercise is super important when it comes to things like security and operations. And it's one of the reasons why being in this business for a long period of time is going to be super important to people, is because there's a lot of not so subtle things that you have to do in order to make things scale and stay up in a sort of environment where there's literally, in a second notice, your traffic patterns can change, your user behavior can change. It's a super dynamic environment, which makes it super exciting, but it makes it super hard. So I don't think we changed any priorities. Yeah.
Who do you think your competition is? Maybe I can comment on.
Who do I think are, well, first of all, I'll say that I think you could speculate a bunch of people are competition. We tend to spend, we're pretty aware of what's going on in the industry, but we tend to be maniacally focused on our customers because we think we've got this great user base and so I would say I spend 90% of my cycles when I have cycles thinking about, hey, I've got these customers and they're telling me what they can't do today, and maybe 10% of my time thinking about competitors. That's not to say that I'm not aware of them. I think there's obvious folks out there. Microsoft's obviously starting to produce something that looks a lot more like a cloud computing platform. They've been talking about it for a while, but really are doing some stuff now. I think there's other folks out there talking about things, maybe doing less or more depending on who they are. I think there's also just a ton of you'll as you research cloud. I think over the next however long this series lasts, I think you're going to find that people use that word in a lot of different ways too. I think 90% of the ways that people use the word cloud are not really competing with this idea that I just told you. There's a lot of other ideas that people are, a lot of them are they're putting cloud on anything they can. And a lot of them there are some other models that are cloud-like. The consumer model is cloud-like, but somewhat different, right? So I think there's quite a few competitors, but I'm not sure I have a ton of comments on one or the other. Go here and then there. Yeah.
What % of Amazon's revenues are AWS, and how big do you see them getting in the next 2, 5, 10 years?
Yeah, no, can't do that. No, we don't break out the revenues for these businesses. These are, what I will say is we've always been super bullish on these businesses. From the get-go, we always knew they'd be long adoption curves. They're significantly ahead of where even some of our boldest bets were. If you look back 5, 6 years ago when we were planning these businesses, and that we all feel, all the way up to Jeff, feel super passionately that this can be a very, very noticeable and substantial business, even in the Amazon.com sort of scheme. Yeah, sorry. Yeah.
With more and more people and businesses moving over to cloud computing, it seems like that's increasing like a ton of storage requirements, and specifically in certain areas. How do you see, or is Amazon looking into kind of different ways to source those data centers with alternative forms of power or distribute the data centers? Do you see that landscape changing in the next 5, 10 years?
Are you asking, do I think the data center technology will shift, or do you think we're focusing on?
Well, kind of both. Like, these data centers, a lot of them seem to be, in certain areas, like a ton of New Jersey outside New York, where a lot of people are, and that's a drain on. I gotta imagine that's a drain on the grid. So finding ways to continue to power up data centers where you need them, or moving them without sacrificing the latency requirements of your customers.
Yeah, fair enough. I think it's an ever-expanding land. So, I get a bunch of different variants of this question. Are we thinking about green power? Are we doing, how are we taxing? And to me, this works out really well because, as I kind of mentioned here, for us, cost is king. Like, we've got to be innovating to drive our costs down. And so, certainly the market does a nice little thing for us. If customers need applications to be in a certain place, then we may not have the elasticity to move them. but we're also innovating in terms of driving down the floor of the cost, both in efficiency. Every ounce of efficiency for us, every watt of power consumed is going straight to our bottom line. And so for us, more so than companies building their own data centers, where convenience might be that they know the guy who runs the data center. For us, and for all cloud providers, I think you're going to see a lot more innovation in terms of finding the right places to put data centers, but also finding ways to drive up the efficiency of the data centers when they have to be in costly locations. So I'm a big believer in economics, and I think this is one of the places where cloud computing is going to produce a greater good, because you're just going to have more smart people focusing on the problem that could be afforded by any single company. Yeah.
I've had a couple of clients that I've put on the Rackspace cloud, so I know you don't want to talk too much about your competitors, but if I'm trying to recommend EC2 to them as opposed to Rackspace, what can I say differentiates you guys? Is it the spot pricing model, or what?
Well, I think there's certainly a lot of functional differences between the services. Spot pricing. I think there's a long history of operational performance that helps. There's an array of services outside of EC2 that do a lot of the heavy lifting in terms of storage and databases and CDNs that people find value in integrating with. And so, Rackspace is definitely a company that's trying to figure out how to turn themselves from a hosting company into a cloud provider. And I think they're starting to emulate a lot of the functionality we have. But I think that if you look at the portfolio of stuff, it's much narrower, just for no other reason than they've just been at it a little less time, maybe. But yeah, I think there's also a lot of good literature out there for consumers in terms of the pros and cons and the differences from a software perspective, and there are some that are significant to people, I think. Yeah.
Got a question on, are you guys concerned in terms of people misusing your technology? Now you empower a lot of small companies and individuals. Someone decides to use that to hack a website, create some code. Are you guys concerned about that?
Certainly concerned. We take abuse super seriously. There's really a very nuanced line to walk between, doing your due diligence for mankind and protecting the privacy of your customers. And we try super hard to walk that nuanced line in the right place. That said, I'm a firm believer that cloud computing is actually long term is going to be less valuable for would-be abusers. And the reason is, once you're able to establish with high confidence that somebody's doing something illegal or nefarious, the ability to stop it if it's in a viable cloud computing provider's cloud is much higher than, for example, the botnets that people run distributed across Russia, Southeast Asia, India, and the US, like these very distributed botnets that you can go and buy on black markets for $10,000 an hour, are much more difficult to control than it is if they put all their data in somebody's data center where a reputable provider, again, we don't touch people's data, but if law enforcement comes along and really gets at that piece of data because the law has been broken, there's to me, that's a less desirable thing if I were going to do something truly illegal. Yeah. Not that I would.
What do you see the future is with MTurk?
MTurk is, so Mechanical Turk is what you're asking about, is our artificial intelligence service. This was one of the first web services we launched, which essentially takes a global workforce and puts an API on top of them so that your application can call humans with significantly less latency than the real world. There's still latency there, somebody's got to get it and do it, but we've done a lot of stuff to make that latency pretty small. I think there's been a ton of interesting use of it. It's definitely growing. It is a seriously disruptive idea that I think people are just beginning to make use of. But there's just a bunch of stuff that computers don't do well. But as more and more, as this whole servicization of the world continues, I think that idea that you can outsource to a human certain function calls is going to become more and more. People are going to do things with it today that we can't even imagine. But some small search companies have been using Mechanical Turk to great effect for things like search relevancy, where you can actually you can start to play with algorithms and present search relevancy to users. Things like social sites when they need to filter for things like questionable photographs. it turns out that humans are much better at that than machines. So to me, I think that's a super innovative idea that has gotten a ton of traction, and I think that if we look ahead 10 years, it's going to be one of those things that surprises us. And sometimes you have to continue to invest in those things, because, yeah.
How does government control on information affect your cloud computing business, and how do you minimize these effects?
One more time, you're asking how government regulation?
Yeah, regulation in terms of information and.
Yeah, I mean, I think they're and people should leave if they need to leave. I'll happy to talk for a little while, but I'm not going to be offended if you leave. Might cool the room off a little. Government regulation, certainly it's something we're interested in. I don't believe that I've personally made any business decisions as a result of potential policy implications, most that would be a foolish thing to do at this stage in the business. And I definitely think that the policy landscape will evolve, and that will impact what cloud computing ultimately becomes. But I think it's early. I don't think there's a lot of regulation out there, and I think that we have to do the right thing for customers, and then that regulation will probably follow suit. I don't believe it's going to pop up and whack us on the head, but who knows? Yeah.
Do you view the number of customers or the complexity of customer needs as a bigger driver of growth? And I guess with that, how much do you have to look into hardware roadmaps from Intel and AMD and the server companies in your capacity decision?
Yeah. Amazon as a company, well before web services, had to stay very abreast of technology changes. You want to anticipate those things well in advance, so we definitely do that. It's all the more important to us. As we get bigger and bigger, we influence that more and more. We don't tend to be surprised too much by where hardware is going and where computing infrastructure is going. I'm not sure I caught your earlier question, which was
I guess
the diversity
the bigger
of workloads.
driver of need for capacity in AWS. You think it's the number of customers as more people come online, or is it the complexity of their needs?
Both. I would say it's a blessing. Both are definitely driving it. Yeah.
So this spot pricing model that
Yeah.
you mentioned, it's almost spot on for scientific research computing needs. I'm not a researcher. But if I may suggest, there may be a model that's better, it won't be almost perfect, where what you usually know is that you have a problem that you want to try, and it's going to involve this much CPU time, and you can wait up to this much to get it. Now, you don't want to bid because you don't want to overbid, but if I could say, okay, I need 100 parallel instances for 2 weeks over the next 6 months, and they don't want to be interrupted more than, let's say, 100 times.
Yep.
What's the price of that? And then you give me the price, and I decide whether that's something that you
Yeah.
should do or not.
So I made a comment earlier about not walking through one-way doors. So that has a whole bunch of tricks, like making a guarantee about capacity. You're subtly making more and more guarantees about that capacity, which of course diminishes the value of that excess capacity to us. Now, I absolutely agree with you that that'll make it more digestible to customers. The nuance in this product definition, which we have actually a couple of folks that are graduated sort of in the last 2 or 3 years, really driving a few folks really thinking about this, because very nuanced changes can have big impacts on both the usefulness to us as well as the ease of customer adoption. But we've done things like show people bid history. The way our algorithms work is we don't charge people. That's at most they pay. They normally pay less. So the overbidding is the way the auction model works that we've chosen. That's actually less of a concern. But I think that a tool like what you're suggesting, where people can give you much higher level guidance and get sort of certainty values computed, like with this level of certainty, I think you'll get that with this bid price, is I think something that could be. And I think there's things we can do there. So I think there's ways to go after. I think that's going to be an area that is going to be. This is an area that gets me super excited because I think it's going to be rife with innovation and clever product ideas. So, and I think your idea is great, and I think there's nuance in there. Yeah, sure. I don't know if your hand's up or down. So.
You mentioned earlier the cost advantage, and it's really clear as we kind of work through it how your customers have a really huge advantage in cloud computing, and then similarly can pass on value to their customers online. So as you think about digital content monetization, people are now trying to charge more for things that are free or once free. Cloud computing kind of could maybe lower the cost of doing business. So how do those things work together? Where do you think we are on the cycle?
I think there is unbelievably high margins in the software industry in terms of not just the hardware providers actually don't make terribly great margins, but if you do some research, you'll see software providers are often sitting on 70, 80% margins. I think that's all going away. Like And that's why I'm excited to work for Amazon, as we're a company that loves small margins and big volumes. And I think that the whole prospect of cloud computing is for entrenched players is actually quite scary, because those margins could go away as things become easier and easier to use, and you don't need as many consultants to come in and actually help you set up X, Y, and Z technology. And so I think there's just so many places in the sort of ecosystem where that value is going to be squeezed out, and it will result in things being cheaper and more ubiquitous and more free storage. And I think there's a whole bunch of trickle-down effects on business and consumers. That said, I think, being the economist that I am, I think that most of those people that are doing those jobs today are going to also innovate on top of the stack, and so they're going to create more value too. So I don't think that money is magically disappearing. I think, tech and innovation is going to continue to be a big place with lots of winners. I just think that a lot of the entrenched margins are going to start to erode as people find value in other places, and I think that will definitely find its way into the sort of value a consumer gets and also the value businesses get. So, yeah.
What kind of adoption are you seeing from companies like banks, which have a lot of issues with keeping their data to themselves and not releasing personally identifiable information outside their domain? How do you see companies like that adopting services like that?
Yeah, I see all sorts of things. I can't comment on specific customers, but I think that you can kind of paint yourself, as you've probably done in your head, a spectrum of sort of data and people's concerns about it. And as I made a comment earlier, where I actually believe that putting your data in a cloud in somebody else's data center, whether it's ours or someone else, is ultimately going to be a more secure proposition than keeping it in your own data center. I think that it's going to take time to establish, and it's going to take some innovation. Like, there's no doubt that there's a whole bunch, we've removed a bunch of threat vectors by moving stuff in the cloud, but we've also introduced them. And so as that innovation increases and increases and increases, I think we're going to end up with a more secure computing environment. And I don't see any fundamental reason, nor do I think a lot of customers out there that are starting to get ahead and think about these things, that any and all data might eventually move into, you may have seen recently we released it's a different to your question, but we recently released a public sector cloud that meets a bunch of the regulations needed by the US government. One specifically is called ITAR, that allows them to put applications and data in the computing environment that I think if you had asked 5 years ago, most people would say that data is not going to the cloud. So, yeah.
Somewhere in the presentation, I heard you mention CDN. Is that a market where AWS wants to go after it? And if so, how are you planning to position yourselves against the Akamai's of the world?
I don't think we necessarily look at the CDN market and say, hey, that's a business we want to be in, necessarily. It's not a business we don't want to be in. I think ultimately what drove us into the CDN business was we had a bunch of customers using S3 to do object distribution, because S3 is really powerful and they needed some latency improvement. And so again, we found ways to, latency is a big deal for all of our services. And so the CDN itself provides a valuable service for us to build a bunch of functionality for people to deal with latency. We kind of built it because we think that having it in our portfolio of services allows us to deliver more value to customers, substantially more value. In most cases, you'll see that AWS is, we basically are doing a ton of work to foster an ecosystem, because that's super important to our business as well. But where we see opportunity for us to innovate for customers, and specifically with relation to our other services, we definitely are going to do that. So that's the case with, yeah.
I was wondering how integrated are your AWS and your web services business and the data center business? Like, do you allow other web services to run into your data center, or do you allow web services to run other web services?
Are you asking, do we own all of our data centers, or do we let people?
Are they like completely working together, or do you consider them as a business?
Web services in Amazon.com?
No, web services in the data center. Like the infrastructure and the web services.
We definitely, a lot of the folks that work on innovating in our data center are in my orgs directly around me, as Amazon itself is a customer of AWS, and so a lot of the innovation we're doing is on behalf, Amazon's consuming AWS, and we're figuring out how to make things super cheap and super reliable for them. So we're definitely focused on, the work we're doing around data centers is focused around AWS. So they're pretty linked concepts in our mind. Yeah.
What's your interaction with the scientific research community in the sense of publication and consumption of research? Do you follow conferences? Do you guys publish at conferences?
Yeah, we do. We do. We tend to, we certainly participate in a whole bunch of different forums for thinking about ideas. We tend to be, we have no particular policy in terms of whether or not people write papers, but we tend to be a quite frugal organization in that we want to spend our precious resources on doing things for customers. And so a lot of times, the sort of overhead of producing a paper, unless we really think it's going to somehow foster the greater good of humanity, and oftentimes the best way to foster the greater good of humanity is to build something as opposed to talk about building something. So we do tend to, I don't think we tend to be as present at a lot of conferences, but it's not a policy thing as much as we're excited to be building things, and that's kind of where we put our energy. Yeah, certainly, and participate. I mean, there's certainly a lot of people at Amazon participate in a lot of different thought forums, but I would say if you look at Amazon as a whole, we tend to be more focused on building than sort of maybe other places. Yeah.
Yeah, you talked about removing the muck, like throughout your whole talk, right?
Yeah.
So you had like the 30-70%.
Yeah.
And I studied security. Huh?
Scientific, well-measured.
Yeah. No, so I study security, so I was curious about hearing maybe if you had more details as how you guys are removing the muck with respect to security in particular, and specifically compliance, like regulatory stuff.
Yeah.
Are you working towards, and do you already have like a standard implementation or set of processes for complying to these different regulations?
So we've done in one way, we've done a bunch of work to make our data centers compliant to a bunch of standards, FSMA, PCI, there's a whole bunch of HIPPO. We've done a bunch of work to, and what that does in terms of removing the muck is, normally those certifications, for instance, not simply because you're running your app on AWS does not imply that you're going to be PCI compliant. However, to become PCI compliant in the real world, you need to do a bunch of work at the application level. You need to do a bunch of work at the infrastructure level to convince the auditors that you're PCI compliant. What we've been able to do is get the infrastructure up to a certain place in the stack pre-certified for customers. And so now when they go to get certified, there's less surface area for them to cover. They can kind of leverage that prior art. Right. Right. So you can certainly put a bunch of credit cards on an EC2 instance and open that instance, put Apache web server there to serve up those credit card numbers for people, and that would not be a PCI compliant application, despite the fact that it's built on EC2 and it itself is PCI compliant. So these compliances are typically quite complicated, but I think over time, as we do more and more in the cloud, the same principles apply, that a lot of the heavy lifting can be done for people. And I think we're not done. We can go higher up the stack and do more for people. You can imagine FPS is our flexible payment service. Using FPS makes it easy for people to do a lot of payments-related activities that if they were doing inside their own application would require an even higher bar for getting a PCI compliant application. So kind of yes. As to what features we have in terms of security, we've done a ton of stuff. The one I'd highlight most for you is the work we've been doing around the virtual private cloud. And so the idea of the virtual private cloud, which is another team that I own, is to basically provide a lot of the high-level security abstractions that customers are familiar with inside of a data center and make it easy for them to apply those to a cloud environment. And so, there the obvious example is the hardened eggshell, the network that surrounds all the boxes, and so they can set up a single set of network ACLs, permissions, that sort of wards off their whole data center, which is what they're familiar with kind of inside the data center now. As I said earlier, there's cloud gives them multiple layers to put that protection in place, and so things that they can't do inside their data center, even with that hardened exterior, there's lots of, people typically talk about security as a hardened, if you look at a typical traditional data center, it's a hardened exterior with a mushy interior. In other words, if you're an attacker and you get inside that data center, typically you can walk around and find all sorts of stuff. With cloud computing, we've done a lot of stuff so that it's pretty easy for customers to put additional segregations inside their environment, so if they do find that they're compromised in some way, that they can provide more blast radius control. And so I firmly believe that you're going to see more and more and more of that.
So what's that called? That's virtual?
VPC, Virtual Private Cloud. Yeah, there's a detail page on that as well if you want to read up on it. Anybody else? Yeah.
You mentioned moving further up the stack.
Yeah.
Maybe talk a little bit more about that. And do you see Amazon programmers eventually building apps for your clients?
Well, say again.
Do you see Amazon programmers actually building products, building things for clients? If they have an idea and they're using EC2, helping them actually build what they want to be built.
You mean like professional services, I think you'd call that. Yeah, we're pretty focused on building services and enabling others to do things like professional services. So whether or not we would do some small amount of professional services are, certainly today, if a big enough customer comes along, I will personally get involved in helping them build something if I think it's important to the business. But as a general rule, we're trying to produce the sort of automation and productization that allows us to bring that to a very large audience. And so that's where our focus is. Yes?
I have a more general question, more from a supply chain perspective.
Sure.
Capacity, do customers have the option to reserve capacity in a way that they buy, or they pay a fee and they don't use it?
Yeah.
And if they can, my other question related to this is, you have these different options of basically storage capacity, the web-based, we have high-performance computing. Is this capacity kind of flexible? For example, you have a higher demand in storage, then you basically can transfer capacity from one to the other. Yeah. I'm not a technical expert. It's really general.
Fair enough. The first question was, do we allow people to reserve capacity? And so I actually talked about two pricing models we have for EC2. One is what we call on demand, and that's the show up and ask us for X, and we'll say yes or no, and you get X and you pay by the hour. The second one was this auction model we call spot. There's a third model, which we call reserved instances, which is useful for customers who know that they're going to run capacity and provides two benefits for them. One benefit is it gives them a guarantee that that capacity is there for them, so we reserve it. And it gives them the ability to get an effectively lower price over a term. Now, the way we've structured that is I would describe it as an option. So in the real world, if you want to reserve capacity, you go out and you buy a physical piece of hardware and you rent a rack, and if you don't end up using it, maybe you can turn the server off, and so maybe you don't pay for the power that it was consuming. And maybe if you're super lucky, you can put it on eBay and sell it. But it's really, you don't get much elasticity at all. With an RI, we wanted to maintain some of the elasticity, but still give people the benefit of a reservation. And so we've structured it like an option. They pay a portion of the amount of the reserved instance up front. In exchange, they get the reserved instance, which then gives them the right to run any hour they want, but at a substantially reduced cost. And so, for instance, you might have a 10-cent an hour instance that they can pay on demand, whereas with an RI, they might pay $200 up front, which gives them the option of running at 3 cents an hour for a year or 3 years. And so typically, if you were to run at steady state over the term, you would get somewhere between, you'd save sort of 30 to 50, 60%, depending on the instance type. So it gives them reduced cost, but it also gives them the certainty. Of course, in exchange, we're getting guidance and sort of, it helps us on the supply chain side. Your other question is much more interesting. And the short answer is it depends. Computing resources are to some degree fungible, but not entirely. So computing resources are machines that have set amounts of disk and memory and CPU, and sometimes you can use that in multiple contexts, and sometimes it's so cost ineffective to use it in this other context that it's smarter to just go buy a different box. Now, there's interesting things you can do. A lot of those servers share parts, and so if you think through it from a supply chain perspective, at scale, there's a whole bunch of interesting things you can do that give you some degree of fungibility, and those are super interesting problems, as they would be in any industry where you're producing these sorts of volumes and you have that sort of capital on the line. So it's a good question. Anyone else? I'm okay with that.